Okay. Good morning, good afternoon, good evening. I am Sandeep Vankre, representing TRIZasia and AISSMS College of Engineering. I am very happy to invite Oliver for today's session, that is chapter 26 of TRIZtalks. So, Oliver, I would request you to briefly introduce yourself and go ahead with your presentation.
Okay, due to time, I have to skip some slides. If you have afterwards, if you have questions, just let me know. You can send me an email, so we can discuss maybe afterwards. So on the next slide, my name is Oliver Gerund. I'm working for Bosch company as a consultant and coach and supporting innovation projects in their work. So systematic creativity, product engineering, and TRIZ is a very important and successful tools that I also used in my 16 years in product development. And so I want to share some experience about the application of TRIZ, how to do it. So maybe very shortly on the next or the slide number 5. Yeah, we can.
Just the one. Okay.
Yeah, so I don't know if you all know the company Bosch. So we have 3 business fields. So in mobility, industrial, energy, building, and consumer goods. And on the next slide, that what I want to say with that, we are a huge company with more than 400,000 people, and of course the influence of one person in the corporate department is limited for 400 people. So the message is, when I tell you what we do in TRIZ, this does not mean that all 400,000 people are knowing TRIZ. So it's for some of them. And we are also working worldwide. So it's also so on the, maybe you can go to the next slide, the 7. What this means, that we are working worldwide, and the main activities for me where I am active is in Europe, but also in the last 3 years in India. And this is what I like very much, and this is really a good practice, a very good example how to implement TRIZ in a company. And this maybe you can also have exchange with Karthik Azukan from Bosch India, who implemented TRIZ there very successfully. So this is mainly Europe, Asia. In the Americas, there's only a little bit TRIZ activities, but here we have most. So how we implemented TRIZ. So the perfect world is that everybody is intrinsic motivated to use TRIZ, and this is not the case, and so it is not also not here for us in Bosch. There are hurdles, or people don't use it because it looks in the beginning a little bit complicated. Yes, it is the case. So it's not really nice that everybody is intrinsic motivated about that. And what is also a barrier, that the top management, and this is why I showed the slide with this more than 400,000 people, we don't have a channel to the highest top management in such a huge company, and so we don't have the promotion for TRIZ. But the question is, what to do if we don't have this top management promotion? So when the top management says, like, we have the case in user experience or design thinking, they say, okay, we need products for for our users to. So there we have this promotion, but we don't have it. And so what we did is one thing, we have founded a core team, a TRIZ core team, TRIZ enthusiasts, and we thought about how can we bring or how can we promote TRIZ in our organization. So there were several approaches, and to spread and make it popular, more popular. There was one channel that is used successfully, I would think, and this is offering training. And we started in the beginning to offer training with an external trainer. This is we still have contact with this external training consultants, but we also offer an in-house training. And this is, of course, on one hand, the sharing of knowledge, how to use TRIZ, and also to show internal examples of TRIZ. And this is a difficulty that you can't discuss with an external trainer. What are the application in a pre-development, in a development phase of a product, for example, due to compliance issues, and not to share too early with the public. But the second, and this is what I want to say, this is very important. A training builds up a network. So this is we are still in contact with many participants of our trainings. So we are at the moment we are 3 trainers, internal trainers, for these TRIZ trainings, and this is really good possibility for spreading it. But afterwards, if you have a 3 days training level 1 or a 4 days training level 2, of course, to use this in a complex daily business, it is not always possible. So what we also offer is a coaching and support for using TRIZ. And so to supporting with organizing a workshop or discussing function analysis results and so on. So there are some faults in is there a question? Do you
Dear
have
participants, keep yourself on mute mode.
Oh, okay.
Yeah, continue, Oliver.
So, okay. So one best practice example is really what Bosch did in India with the main Karthik. I don't know if you are in the line. I don't see it on my small smartphone. But he organized training, organizing a network and a support, and he's really good sparring partner to how to implement it in your part. And then working in a network, this is also in the end when I say what are my learnings, this is don't use TRIZ alone. Work together, connecting with others, TRIZ guys. So on the next slide, the 9, and this is what is for me the next 3 slides, the basic message of TRIZ. So we as humans have when we hear or when we are faced with a problem. We are always thinking in solutions. This is in our DNA. So only thinking in solutions, and this is also the biggest barrier that I see in the beginning when we teach people using trees and they get a problem. So a problem in the sense of a positive thing. So we have something to work on. Yeah, we have a task. So problem for me is a positive thing. So this is the most difficult to bring people away from this mental inertia. So on the one hand, and this is the first thing, we have a contradiction. On the one hand, we want to have a good experience so we know a lot, but this brings us also this mental inertia. So the sense of trees in the next slide is not to think directly about the special solution, but working on the problem. So with analysis, analyzing this problem, thinking about the problem. Do we work on the right problem? Is it, or do we only work on the results of the real problem? So finding a general problem, an abstract problem, so we can look if others also had a similar problem on an abstract level, and so others also have good solutions. So we can see with our 40 inventive principles how others solved a problem on this abstract level and transfer this to our topic. So we have a general solution, and then with this topic we have the creative part, and this is the creative work, how to transfer this to a special solution, and how to decide which is for us the best solution. So what I like very much is from Akao, the inventor of the quality function deployment, QFD. He said, copy the spirit, not the form. And I like this very much. So in the beginning, we had also questions, what is the difference between DRBFM and trees? And we have also often for design for Six Sigma and all these things. There are many links together, but the core is, for me, this picture here. As simple as it looks like, but it is the core of trees to think about the problem, the analysis, and not heading there directly to the solution. So copying the spirit, not the form. So as you saw in the very short introduction in the beginning, I'm working in the central department for user experience. So user experience, for a definition, is in the case the implementation of design thinking. So a little bit more a wider approach of design thinking. Design thinking is the tool, the mindset behind it is UX, the user experience. So they work with the so-called double diamond model. So understanding in the beginning what is our problem, what insights do we have, what's the English word? To concentrate these insights. This is in the second phase, synthesize. Sorry, and after after concentrated these or have the essence of these insights, they come to the point in the middle after the first diamond, and there's the so-called question zero. And for this question zero, this is the concentration. What is the real problem that we have to work on, for what we have to find solutions? And then they are starting also in the difficult thinking, how to ideate, how to find solutions, how can we do it, how can we realize it, and building up prototypes. So they call it MVP, minimum viable product, and bringing it to the customer to test, to gather feedback, and making maybe once again the next session again to make improvements. And this is not so far away from this, what we do in our TRIZ procedure model. So this is what I did. I compared these two approaches, as we see on the next slide, and said, okay, for this on an abstract level, what they are doing in user experience and what they are doing in their design thinking process, and what are we doing, and brought this together. I compared this on a table in the next slide 13. So we don't have to go through all these tools. You can read faster as I can do. What I want to show you is on the right side in this red box. I said, okay, like a cow, copy the spirit, not the form. What is the sense? Why do we do the one or the other tool in this or that phase? So it's, in the beginning, it's planning. So we have the innovation checklist, ISQ, and so on. And then we try to make a deep understanding. So so we have a function analysis, resources analysis, the 9 boxes, the thinking in time and scale, and so on. So you see on an abstract level, we are doing almost similar things, of course, with other tools, and we have different different kinds of problems. So the task for me was to promote TRIZ in a world, and all my colleagues, I think in my department, 90% of my colleagues are designers. So we have to learn from each other, and also to make the best out of it. So this is when we work together on a project. This is on the next slide, the 14. I show you when is TRIZ the right tool. So on the x-axis we have the certainty. So on the left side we don't know, hey, what is our problem? What is we have a high uncertainty, and in the flow of a project we gain certainty. On the y-axis we have the complexity. So where you use experience or design thinking, when you have not a very high complexity, maybe it is complicated. Then we have these phases of understand. So this is where the design thinking with stakeholder research and pains and gains and things. This is a very good approach to understand who is the customer, what is the need of a customer, of the user, and what problem we want to solve. Here, when we have a high complexity, the TRIZ brings much more advantages, like these 9 boxes, thinking in time and scale, and this function analysis, root conflict analysis, and so on. And while the design thinker in this synthesize phase are working with e.g. with a value proposition, what they want to bring to the customer, what is their value proposition. There also TRIZ has its strengths in the tool set, how to find this. So we have technological trends, the trends of engineering system evolution. We have separation principles to work on these complex questions and so on. I think the biggest disadvantage is in this design thinking and also other approaches like DRBFM or FMEA. In this phase of an ideation, all the other tools are very quiet. So mostly, as I saw in these now 24 years in development and innovation projects, so mostly brainstorming is used. Maybe a little bit inspiration by competitors, looking what are competitors doing, or patent analysis. But mostly it's a kind of a brainstorming. And so here in this complex world, TRIZ has its highest advantage. What I learned in using TRIZ is it doesn't matter how complex and how difficult the question is. With TRIZ, you can be sure you have an additional idea. And if you had this idea, you have even one idea more and more and more. So this is a good advantage, and it is a targeted ideas. So we are going into this in your ideal direction. If we find a solution, this is fine, and maybe it's the best solution in our concrete solution then. But here stops TRIZ, and in these gathering feedback, testing, looking what are the users doing with our products. Here again, user experience and design thinking has its strengths, and this is what I do. That I like to support the user experience and design thinkers with TRIZ, and this fits very good together. That leads me to another topic on the next slide. What I want to show on slide 15, that we have one tool, and this is for me the most successful tool or the most important tool. This is the function analysis. We see here a lot of application of the function analysis, but why I do this is on slide 16. When we talk about, so we have a system in our mind. This is a system can be a technical system, a complex problem, a quality problem in production, or something. What is our next generation for our customers? Doesn't matter. So we have a complex system with players, and when we talk to each other, the language is working in one by one information. So what is the picture of that? What I said could be different in people's mind with whom I talk together. On the next slide, when I have a picture of a system, so I show how it really looks like. This is the biggest advantage. We talk together about the same thing and the same problem because we have a picture on the wall. So this is why I like to work with the function analysis, and maybe you can go to the over next slide. I wanted to show you a short example. This is a very simple example. It's just a bit holder. So we have this bit holder is a bolt, a magnet, and a sleeve, and this holds a bit. And with this bit, we drive a screw with an electric screwdriver. And here we have a problem when we want to just a scenario. We want to improve it. And if we have a strong magnet in the beginning, it is difficult to pull it out if you have to change it. But you want a strong magnet, so you can't lose this bit. Or you make a weaker magnet, so you can change it very easily. But maybe the bit can get lost. So this is a contradiction. So description. This is our core problem. So we want on the one hand a strong magnet and a weak magnet, and on the next slide, in the first step, we have to define what is our system. Also what is our target component. So here we say it's the screw, so the bit is part of the system, and this is our defense around our problem. So maybe we can skip the next slide due to time. Can go once again. So what we do, and this is very systematic here, of course, for a very simple problem, but it also works with very complex systems. So first step, we make an interaction. We see which component is interacting with which other component. So this helps us not to forget a function, an interaction. So the function defined in trees is an interaction between components. This is important. So this is inside the rules of trees. And then we see what is the function. So for each interaction, we have one function, sometimes two functions, sometimes also if you don't change a parameter or hold it actively, we have no function. So deriving from this, we see that we can on next slide, we can derive a picture of our system. So with this picture, this where we see all components and these interaction, when we have for a complex system, we have such a picture, then we have in a discussion the same picture, and we can analyze all interactions. So behind every arrow, there's a kind of an energy. So we have mechanical energy. So one component is holding the other. So this dotted arrow, it's not very good, and so on. So this is the first step in an analysis of the problem, and to see on which in which spots do we have a problem, something to do, and if we found this spot that maybe leads to secondary problems, if we found these spots, we have the first step, or this is the success factor for finding good solutions. You saw in this slide before that we have several systematic steps, and for those of you who also already work with trees, for you it is not new. What I do, what I want to show you is a best practice example on the next slide. I change a little bit the rules of matrix rules. So don't use this way of finding the function analysis. Don't use this in your certification test for level 1 because it is not liked. I don't make this interaction analysis as a symmetric matrix. I change it a little bit, and as you see on these red arrows, there's a direction of reading this table. So we have the components in a column and also in this row, and we say like here this we ask what is the sleeve doing with the magnet. So the sleeve here is a function carrier, and the magnet is the object of the function. And in this, instead of this cross, there is a interaction. I already write this the function in it and say, is it useful, normal, or is it harmful? Or are there two functions or whatever? That helps me to save one step. And in my experience, the discussion or the thinking process is more exact. This is what I like with this with this way of doing, but it is not in the clear rules of the certification, of course. Yeah, maybe something to bring it with me. Maybe also a question: Are we fixed on the time of so we have 10 minutes left? Is this right?
We can continue, Oliver. Not a problem.
Okay.
Because we started late, so we'll continue.
Okay. So okay, this is just to know. Okay, and then maybe you can go to 26, slide 26. So what are we doing with this function analysis? And then the next one. So what to do with this function analysis? This is a basis for many further steps. So it's this is also the effort to derive such a function analysis is worth, because you can continue with just the improvement. Yeah, seeing. You have contradictions in it. Like I said, we want to have a strong magnet and a weak magnet to improve the system. We can also say to make a cost work to make to save money. So competitors' pressure is to make our components or our systems cheaper, or improve function, depends on, or we can also do a patent circumvention. So one point is maybe on the next slide, the key learnings about how to work with the function analysis. So really, I want to say, if you start working with trees, start with the function analysis. And in the work I'm working very often, because I'm as a coach and consulting, I'm working with teams together. Developing such a model with a team is exhausting. And in my experience, it's better to prepare it alone. So I try to understand the system with a cross-section pictures and stuff and their descriptions, and prepare such a model alone. And then I bring such a model, this function model, to the team and discuss it. And so for us as people, and there I'm not better than someone else. It's always easier to change something as starting on a white sheet of paper. So this is why I would say, if you start working with this function analysis, make the first revision alone in a quiet room, at the quiet desk, and sharing it and changing it in the next step. So on the next slide, also I want to promote a little bit some tools. You see, so that are worked with my in my experience. If you focus on two topics, like we see here, this magnet thing, to improve such an interaction, and this is of course a very focused view, and we have here two components and an arrow in between, and this arrow is always a kind of energy. This energy is for physicians sometimes a little bit difficult to understand, because they are called fields. So for a physician field, there are only 3 fields for a physician. In the trees, in the sense of energy, there are more. So on the next, next slide, once again. So there's a tool or a tool set, I would say. This is the substance field analysis. And this substance field analysis means that there are substances and fields, and they define a problem. So you can show a problem. On the next slide, on the next slide, you see here we have kind of a tool and an object and then field. So the classical situation and interaction between components can be drawn, can be shown like such an abstract model. So when we have a problem, we can show it in such a way, and how to solve this problem. Then for this we have the standard solutions. So there are 76 standard solutions. In literature you find some additional or some summarized some of them, but in the original sense we have these 76 standard solutions, and they work very well. And I want to promote it a little bit to step into this tool. What does this mean? On the next slide, a very simple example. So you have an initial problem, and you see this how it's called, let's say, bridge diagram that I showed you in the beginning, how to work with trees. We have an initial concrete problem. We have a piece of chocolate in our hand, and it melts, and you have the melted chocolate on your hand. This is a problem. So to show this and to analyze this problem, And you can visualize this with such a substance field analysis. So we have the hand as a tool. The hand melts this chocolate, and this is a thermal field. So the temperature is too high, so the chocolate melts, and we can see this is an abstract description. And in the 76 standard solutions, we find possible solutions for and this is formulated as principles. So here for harmful effects, we have the group 1 to 1, for example. They say, okay, bring something. If you have a harmful effect, bring something in between to stop this harmful. Of course, we all know already this sugar, and this sugar is not only for to get more calories. It also have the sense, if you hold it in your hand, you have no contact with the chocolate directly. To transfer this to the next slide, to our problem, is we have this sleeve, we have this magnet, and then so in the first scenario we say, okay, we have a weak magnet, so the bit can be lost. So we have an insufficient on the right side in this diagram. We can formulate this problem as an insufficient function between the magnet, the so-called tool in our subfield, and the bit. For insufficient functions, we can use the standards 112 to 118. And so how to use this on the next, how such a solution looks like. We find this on the next slide. Okay, so the standard 113 says, okay, if you have the problem of an insufficient interaction between two components, build a more complex substance field model with an external additive. So you can here on the left bottom side, this diagram, you see these bubble S3. So to bring an additional substance into the system, especially here to the magnet, to the tool, to improve this interaction between magnet and bit. So here, this is an abstract solution of your problem. So in this bridge model on the right top side, so we have an additional substance, and we have now a normal interaction between the magnet and the bit. It's not longer dotted. It's a complete line. So we have a good interaction. So how to transfer it, come to from the abstract solution to the concrete solution, to bring an additional a clip or something. Yeah, so we can use a weaker magnet plus such a bit. So on the next slide, just some additional examples. So maybe you can read it afterwards. Can you go to slide 40 with the summary? So I skipped this due to the time. Next one, now here. So I want to promote, just step in and let you in. I know it looks and feels complicated in the beginning. In the beginning, you are lost, but try it out. Don't let frustrate yourself. If you try it from time to time, they lose their complexity. And but it's a very good possibility to work alone at the desk, and you're thinking about the problem. But for using it in a team, you can derive questions, concrete questions, because if you don't know this how to work with it, if you're working with other TRIZ experts, it's no problem. But if you work with people who don't know what are you doing there, then it's easier to translate these abstract solutions that you find in these 76 standard solutions to translate them in a kind of a concrete question or a hint. The next possibility is a value analysis and trimming. So on the maybe on slide 43, maybe you can go there. No, next one. Next one. So to see how can we improve the cost situation of a system, and here no, one slide before. Yeah, okay, thanks. We can give a value to all these functions, these interactions. They cost money. Every interaction is an interface, and here we have requirements and things. And this costs money. So what I like here is compared to another or a standard function cost analysis, that we have clear rules here in TRIZ. So we're starting in at the target component here. The screw. This is the basic function. So the bits drives this, the screw, and we have clear rules and can derive later a diagram, standardized function value over standardized costs on the left side, and can they then say, okay, depending on the position in such a diagram, is it a classical cost reduction, or is it it's a cheap component and it has low functions? Can we increase a function, or can we delete the complete component to trim it? I don't want to go to these trimming rules in detail. If you have questions there, we can you can contact me. But on the next, maybe you can go to 47. Once further, next one. Next one. Next one. Yeah, okay, this is right. So we have that we get for most systems, we can get very good results with this approach without a long discussion, because we have clear rules, and then a normal technical system, this works very good. But in my experience, even in components that are consumer goods, like electric driver or washing machines, or where we have a direct interaction with our users, the way of TRIZ is how to find this function value is sometimes a little bit different. And a very simple example on the next slide shows a bottle opener. And so we have a bottle opener, a key ring, connection ring, and we have also advertisement on it. So there is someone, so it's a giveaway, it's a gift. So the people who are printing their advertisement on this they are paying for this bottle opener. The person who uses this bottle opener and puts it to their key, they have a completely different goal. They have a different target. They don't, maybe most of them, don't care about the advertisement, but so there are different objects of the function also. So when we do this this function analysis on the next slide. We have a function analysis and can derive this this cost diagram on the right side. We see that the advertisement has a low function, also same as the ring. So it depends. Is this really the real world? So sometimes in such systems, it is a little bit. I would say, yeah, it does not show the real world. So when you see when you're working in the in your project and you see the diagram after such an analysis, you say no, this is not reality. On the slide 50, and here again, it's not like the rules. So you should learn, of course, the real way how to find a function value. What I developed in a thesis is kind of a workaround. So it's just a best practice. If you take all these functions, so for every arrow, so every interaction between components, every function, and you put it to such a pairwise comparison diagram, and this is what's called antisymmetric. So if we say the bottle opener moves the crown cap, and say, okay, and the bottle opener holds advertisement, and we say, okay, what is more important? Is it the same? Then we make a 1 in it. If we say the bottle opener moves crown cap is more important for the user or for us, as a bottle opener holds the advertisement, we put in a 2. And on the other side, we have then a 0. So it's when we have there a 2, on the other side we have a 0. I don't have a mouse at the moment to show you, but it is like antisymmetric. And we say, okay, we don't have clear rules for this, but it is a good gut feeling, and we have a lot of small comparisons, and so this leads to the case that this analysis in general is also robust. So we can make a robustness analysis. And so we get another kind of a diagram on the right side. So the advertisement rises. So the new advertisement bubble is the value of this advertisement is higher as it was before. The core component, the bottle opener, this is the main function. The bottle opener should open a bottle. This is still the highest value, and here also the highest cost. But the importance of this of the rings, for example, they are lower. So this is in the end here. It shows that it shows the reality better. Of course, it's against the clear matrix rules, and okay, we know this, but for such kind of analysis, it helps, and to correct it a little bit. The disadvantage is we don't have the clear rules. So the patent analysis, I want to skip. I can come now to the last point. Can you go please to the to 56, the slide 56? So this is okay. There was one question in before that you sent me in before. Can we we have large language models, we have ChatGPT and several others. Why do we use trees, or why do we need trees when we have these large language models? And in this bridge diagram in the beginning, we saw, okay, we don't want to, with trees, we don't want to go directly to the solution. We want to make an analysis. And the most important thing in solving problems is to have the right question. And this is the strength of trees, is to bring the problem to a very strong question and the problem that you want to solve. And this fits perfectly to how to work with AI and the large language model. So the success factor to use a large language model, to use AI, is to have the good question. If you have a stupid question to a large language model, the answer is not very intelligent. The same if you can't search in Google, you will not get good result. So this is why the prompt, so the question to our large language model, is important. I did this as this, of course, again, as a simple example. So I said I have here a problem, and say, okay, I want to bring this contradiction. Said, okay, in which field? So the magnet should be strong to hold the bit reliably, and the magnet should be weak so the bit can be changed easily. This means that we have here this physical contradiction, or we gave the large language model as a physical contradiction. The magnet should be strong to hold the bit, and the magnet should be weak. So we have two states of a parameter for different reasons, and bring it around it. So you see the answer was, okay, we had here a quick release mechanisms. Yeah, not so bad. We found this in you remember, in the substance field analysis with this additional clip. Or the sliding cover is also not so bad. And here a dual magnet system. So you can ask again. So three ideas, maybe not so bad. Okay, not concrete, but we can ask more and say, okay, what do you need with this dual magnet system? How does this work? So here it was not to make a switchable a magnet. Of course, you can make an electromagnet with and use another current. Okay, this is possible, but one here was okay. It's not so simple mechanisms such as a sliding switch or a button, which would allow the user to toggle between two magnet configurations. Okay, and I said, let's make the weak magnet. The weakest magnet is no magnet. Yeah, so maybe a new idea. You press the magnet to the side, and you can take it out very easily. So the conclusion of this is use AI to support it. It's only a tool. It's not it does not ersetzen. So it's not the case that you don't use trees anymore. You can improve trees, and with trees you can improve an AI solutions. So the prompt is the most important thing, and writing a good prompt with a good basis. You can also feed it with the standard solutions. You can feed the AI with inventive principles. So finding a good prompt with trees is more easy, and yeah, and it can support you to find a solution. So try it out. to use trees in working with AI. So I come to my conclusion on the next slide. The summary. Okay, no. Okay, yeah. This I already said. Yeah. Okay. Then the next. Okay, thank you. So the summary in many years of using trees: relax and use trees. Try it out. You will have success. And copy the spirit, not the form. Don't use it too dogmatic. I don't know if it is the right word, but use it and yeah, and that's it in the end. So my key learnings to work with trees on the next slide. It changes the way of thinking, and this is really the case. So if you are used to work with trees, you don't step in directly into the solutions. Your mind gets more flexible, and sharing and learn from each other is also a success factor. If you only work with trees always alone, the energy will get lost. And what I also like is this is to combine it with other tools like DRBFM or FMEA or Design for Six Sigma. So like in DRBFM, you're looking for concerns when you make changes, and you see concerns, and there DRBFM stops. So if you found a concern, for example, you can develop this concern to a contradiction, and then you have the possibility to find a solution for that. And so is trees is so successful, I would say, or also so valuable. Because you can combine it with all these other tools. It's not either the one or the other. It's the combination is the success. So on the next slide, thank you for your attention, and sorry for the problems in the beginning, but I can change such a big firewall. Okay, thank you.
Thank you so much, Oliver, for the wonderful presentation. And the forum is now open. Participants, if you have any question, feel free to ask. You can unmute yourself and ask the questions directly. Or if you have some challenges, you can just put it in message, and we can ask this on your behalf. Any questions?
Yes, I am Hemant Pardikar.
Yes, sir. Please go ahead.
Am I audible?
Yeah.
See, can we go to slide number 14?
Mm-hmm.
Here it is.
Yes. So the last yellow square, realize test and gather feedback. We can do this thing even in TRIZ by using anticipatory failure analysis.
Yes. Yes. This is
so Ms. TRIZ can. Sorry, go ahead.
No, your question.
Ahead.
Sorry, I interrupted you. Yeah, I love this anticipatory failure detection, and this is a really nice tool, and it brings your system to a higher maturity. I like using it in a QFT and also in a FMEA topics, and this is really very helpful to use this your creativity to find failures. How can something get wrong, and this is really good, but it does not it does not replace a user test. Maybe you can save 1 or 2 circles in these user tests. But I would before I bring a product to the market, the user test also should be done, and the researchers, the professional researchers, and how to get feedback and to observe your customer by using your products. This gives you insights. But you are right. The failure detection is a great tool, really, and you're stepping into this feedback on a higher maturity with TRIZ, I would say. Yes.
Okay, thank you.
Any other question?
Yeah, I have one question, Professor Wankhede.
Yeah, go ahead.
Shall I? Okay. First of all, thanks, Oliver. It's a wonderful presentation and very insightful. The only one question which I have, where you talked about like TRIZ is giving very good, insightful thought process to make what kind of prompt which we can utilize the latest technology, especially the artificial intelligence or the AI. Do you feel that that AI will take over the human intelligence? I mean to say, and definitely, I would like to know from your experience. Still, human intelligence is still valid, and we need to believe on our own intuition and the creativity in AI world.
I'm not sure if I understood right. So your question is that we still need our creativity for
Yes.
Okay. Yes, this is my really my deep thinking that large language models, AI, all tools in the world will not replace our creativity, because we have so maybe not for all times, but I'm sure the next many years I will not see this as long as I live, because we have many different applications, and we tools and AI show us examples how we can do it, but the last adaptation to our concrete problem, and if we like it or not, and the feeling and what happens, you see two things. So very analytically perfect products, but they have no success on the market, and nobody knows the reasons, because we are not very analytical humans. So we behave in a different way. We see we are not calculatable. This is why I think our creativity is needed. But with tools, maybe we can improve the creativity and get inspiration and things. So AI will not replace our jobs. I think we have a great tool to improve all our doing.
Thanks, Oliver. Like I understood, like a tool we can use for enablement of our own creativity and make it more agile and faster. Am I right? The takeaway.
Yeah. Thank you.
Thank you.
So it's for me sometimes complex to explain in English. Yeah. Okay.
No, you were pretty clear about it. That is not a problem. And thanks for the respite that still the natural intelligence is going to help us.
Yeah, that's my hope.
Any other question?
Yeah, Sandeep sir, this is
Yes,
Harsha.
please go ahead. Please go.
Yeah. Oliver, thanks a lot for this elaborate presentation and sharing the experiences from your organization. In one of the slides where you have given a diagram showing flow of methods, where patent portfolio, problem solving, cost reduction, these were the representative benefits you have mentioned by applying the TRIZ methodology. Okay. So as far as the cost reduction is concerned, I was just curious to know how it is measured in your projects at Bosch, like before and after, or any other method.
Yeah, so this is in our serious product it is a standard that we are working on these cost issues every year, and in the big product areas there are people, they are only responsible for cost work. So of course we have we are using function cost analysis and also finding solutions how to make it a product cheaper. What I do is, and this is also not classical matrix rules, is to when I have one complex element in a system, one Bauteil, one part in our bill of material, and it is complex and expensive, then you can say every design element, so every groove or a surface, is an own component in a function analysis. And you have the assembly is so it's a turned or a hole is drilled, or you have a you have a small tolerances and things, and then you can trim also design elements. And this is sometimes you have to be a little bit creative how to adapt the rules of a function analysis to this topic. But this is successful for discussing with a supplier that makes the part for you, or also in the assembly, to work on these cost topics. On the other hand, the cost work very often is in how to manufacture it, how to make a manufacturing process. And trimming for processes is also a tool where you can use TRIZ very good. This is the second. And the third approach to work on or to reduce costs in a product is organizational contradictions. So on the one hand, you want to produce the whole amount of parts in one plant, due to benefit in machines, you need less investment, and you want to manufacture the part in Asia Pacific, Europe, and the Americas due to tax issues. So this is a classical a contradiction formulated as a physical contradiction or engineering contradiction, and you can also transfer inventive principles for organizational problems. This is a third one where you can use TRIZ, and I do at the moment, the last 2 years, I have a lot of projects to work on cost issues with TRIZ. This is used very often, and we have success stories about that. We're talking about that internally, and so this is a big amount of my tasks in my daily business, this cost work with TRIZ.
Okay, thank you, Oliver.
Thank you, Oliver.
You're welcome. You're welcome.
Is there any quick question? We can take it one. And okay, thank you, Oliver. It was, of course, initially there were some challenges, but later it went very well. And looking forward to have more interaction with you. Participants, if you have any question, any doubt, you can just reach out to info@trizasia.com and we'll pose your question to Oliver, and on his behalf, we assure that you will get the answers. And with this, we end with the chapter 26 of TRIZtalks. And we'll be coming with TRIZtalks 27 on the 25th of October, which is the last Friday at the same time, 4 o'clock. And looking forward to see you all over there. Thanks again, Oliver, and thank you all the participants to be there and be interactive during the session.
Okay, thank you. You're welcome, and looking forward to it. And just feel free and contact me for questions. No problem.
Sure, Oliver. It was a wonderful presentation. Thanks a lot for that.
Okay, thank you. Bye-bye.
Okay, bye-bye.
Thank you all. Have a nice day. Bye-bye.